In this lesson, we're going to answer the question, how do I find the surface area of triangular prisms? So before we get into actually finding surface area of triangular prisms, let's talk about triangles. Take a look at our first triangle. First, we're going to find the area, and we have to remember how we find the area of triangles. The formula is area equals 1/2 base times height, also known as base times height divided by 2, which a lot of you prefer to do. So in this case, in this triangle, we have a base of 6 and we have a height of 5. So we would have to do 6 times 5, which is our base times our height. That gives us 30. And then when we cut it in half, we get 15 square centimeters. Now let's talk about what kind of triangle this is. We're going to name it by its sides. I know some of you may look at it and go, oh, it's an acute triangle because all the angles are acute angles. And you would be correct. But if we're naming it by its sides, this is an equilateral triangle. In an equilateral triangle, all the sides are exactly the same. So every side of this triangle is 6 centimeters. So they're all equal, hence the name equilateral. In this next triangle here, again, we're going to find the area, base times height divided by 2. Here's our base, which is 8. Our height is 8. Remember, base and height need to be perpendicular. 8 times 8 is 64. When we cut that in half, we get 32. So 32 square centimeters. Now, you may look at this and go, well, Miss Sexton, that's a right triangle, and you would be correct. But if we're naming it by its sides, notice that we have 2 sides that are 8 centimeters, and then we have that one that's 10. Because we have 2 sides that are the same, we would say this is an isosceles triangle. 2 sides are the same. And last, we have another, what looks like another right triangle here. First, we're going to find the area. We have to do base times height, so 6 times 11, which would give you 66. But again, don't forget to cut it in half, divide by 2, and you would get 33 square centimeters. Now, if we name this one, alright, and then the type of triangle here, we have 3 different sides. We have one side that's 6, one side that's 11, one side that's 12. When we have sides that are all different, we call that a scalene triangle. So now we're going to talk about why you need to know what kind of triangle it is, whether you have equilateral, all the sides being the same, whether you have isosceles, 2 of the sides being the same, or whether you have scalene, where none of the sides are the same. Take a look at this triangular prism. Now, we don't really have a formula for triangular prisms, but we can use that idea of finding the area of each face and then adding them all up. Notice that we have 5 faces. We have 2 triangles, and we have 3 rectangles that go around those 2 triangles. Let's start with the triangles. Notice this triangle right in the front here has these little dashes. Those little dashes are telling you that all the sides are the same. All the sides are the same measure. That means if you look in the back here, do you notice how this side is 7? If that side is 7, guess what? So is this side, so is this side. We have an equilateral triangle here. All of the sides are exactly the same. So if I find the area of one triangle, I can find the area of the other triangle. We have 2 equilateral triangles. So let's see, for the triangles, I'm going to do 1/2 base times height. So my base is 7, because all the sides are 7. My height is 6. Don't forget your height is perpendicular to our base. And then, of course, divided by 2. 7 times 6 is 42. And when you cut it in half, you get 21 square centimeters. But that's just for one triangle. I'm going to times it by 2 because I have 2 triangles. So the triangles are 42 square centimeters. So triangles are done. Now let's talk about the rectangles, those 3 rectangles. Now here's the cool part about equilateral triangles. If every side of your triangle is exactly the same, think about how that affects your rectangles. That means that the width of your rectangles are all going to be 7. And of course the length of your rectangle is definitely going to be 12. So it's pretty sweet. All of your rectangles are going to be the same if you have an equilateral triangle. So if you find the area of one rectangle, then you really know the area of all 3 of them because they're all the same with an equilateral triangle. So let's look at our rectangles here. Our length times our width would be 12 times 7. And that's going to give us 84 square centimeters. But remember, we have 3 rectangles. That's just one rectangle. So now I have to take my 84 and times it by 3. And that means I'm now going to have 252 square centimeters. So I have the area of all the rectangles, the area of all the triangles, and all I have left to do is add them up. 252 for the rectangles plus 42 for the triangles, and that's going to give me 294 square centimeters. Alright, let's do another one. Take a look at this triangular prism. Notice now we have only 2 dashes. That means that these 2 sides, this side here and this side here, are the same, but this side is different. So we have 7 here, 4 at the bottom. That means that we have an isosceles triangle. 2 sides are the same, one side is different. Let's start by finding the area of those isosceles triangles. So I'm going to write triangle here, or triangles. And it looks like my base here is 4. My height is actually over here, it's 6. Do you see how the height, they extended it outside of the prism? You could write it inside if you wanted, but it is 6 centimeters tall. And of course divided by 2. 4 times 6 is 24, divided by 2 gives you 12. So it's 12 square centimeters for one triangle, but 2 triangles. That means it's 24 square centimeters for those 2 triangles. Now let's look at the rectangles. Now if you remember from the last slide, if you have an equilateral triangle, all the rectangles are exactly the same. Well, in an isosceles, or when you have isosceles triangles in your prism, you now are going to have 2 rectangles that are the same, and then one's going to be different. The 2 that are going to be the same are going to be the ones that have 7 as their width. So we had 7 here, which means we have 7 over here, and our, of course, length is 12. So 7 times 12 would be for this rectangle right here. And another rectangle that would be 7 times 12 would be this one right back here. Because if this is 7, this is 7, so you know your widths are 7, and of course 12 is the length of the whole prism, so 7 times 12 again. So here 7 times 12 is 84 square centimeters. Those are just for the 2 rectangles that are the same. There's one rectangle that's different though, we have to keep that in mind. The one that's different is the one that's at the very bottom. Let's see, I'll get green to highlight it. This one right down here is the one that's different. It still has 12 for its length, but its width is now going to be 4. These 2 sides here are 4. So I have to do 4 times 12, which gives me 48 square centimeters. And now I'm going to add them up to get the total for the rectangles. So I have to do 84 plus 48. And that's going to give me 132 square centimeters. So here we have 2 triangles, both of them total area is 24. The 3 rectangles is 132, so now I'm going to put it all together, 132 plus 24, and that's going to give me a total of 156 square centimeters. So when you have isosceles triangles in your prism, 2 rectangles will be the same, 1 will be different. Alright, one more to go. Well, we covered equilateral triangles, we covered isosceles triangles. Here we have an example of scalene triangles in our prism. So let's start with those scalene triangles. We know that every side is different. But let's first figure out our area. We have to do base times height, which would be 3 times 4. So this is for the triangles. And you know that our bases are exactly the same, so once you have one triangle, you have the other. 3 times 4 divided by 2 would be the area of one of the triangles. 3 times 4 is 12, divided by 2 is 6. But we have two triangles, so we actually have 12 square centimeters for the area of our two scalene triangles. And now let's talk rectangles. You know that if you have a scalene triangle now, all of your rectangles are going to have a different area because the widths of those rectangles are all going to be different. So, for example, let's look at the rectangle that's at the very bottom. So the one at the very bottom has a width of 4 and a length of 11. So you would have to do 11 times 4 to find the area of that bottom rectangle. Maybe I'll write bottom next to it so you recognize that it's the bottom one. Let's see, we also have a rectangle on the right side. So here's the one that looks like, I guess, top right, you could say. This rectangle right here. This one still has, you know, that length of 11, that's not changing, but the width of it is now 5. So we have to do 11 times 5, which would be 55 square centimeters for that rectangle. I'll say top right. Alright, and last, then we have the one on the left-hand side right here. So this one again is going to have its length of 11, that's staying the same, but the width is now 3. So I have to do 11 times 3, which is going to give me 33 square centimeters for the left rectangle. So all three rectangles are different when you have a scalene triangle. Now all I have to do is add them all up. I have to add the 12 from the two triangles, the 44 from the bottom rectangle, the 55 from the top right rectangle, and 33 from the left rectangle. So when I add them all up, you can use your calculator. 12 plus 44 plus 55 plus 33 is going to give me a total of 144 square centimeters. Alright, so here are the takeaways. If you want to find the surface area of a triangular prism, you have to find the area of each face and then add them all up. And just keep in mind, if you have equilateral triangles for your bases, all three of the rectangles will have the same area. If you have isosceles triangles for your bases, then 2 of the 3 rectangles will have the same area. But if you have scalene triangles for your bases, each rectangle will have a different area.